We have to treat solids and liquids a little bit differently because we describe the equilibrium expression as being the concentrations of reactants and products. Well, when we have pure solids and pure liquids, their concentrations don't change. The amount, the sheer amount of it could change, but if you have water, the amount of water in a given volume is always the same. And so we can't really talk about their concentrations changing. So what we do for those is we just leave those guys out. Makes things much simpler. We don't actually have to go and try to figure out what's the concentration of calcium carbonate. It's not going to change, so then we don't care what it is. So we leave it out. And here, calcium oxide, it's a solid. So when we write the equilibrium expression for this reaction, it becomes very simple. It's just the concentration of CO2, because the concentration of calcium oxide and calcium carbonate doesn't change. So if you see S or L as the, lost my words, physical state, the phase of the reactant or product, you just leave them out of the equilibrium expression. Let's do an example. Let's write an equilibrium expression for this guy. So are there any of these that we can leave out? Yeah. This is a liquid. We don't have to include that because it's not going to change. So then KEQ, what am I going to put in the numerator? The top. Cl2 raised to what power? Squared. And that's going to be divided by HCl to what power? The fourth power. And O2 to what power? The first power. So we don't need to write that. So that's the equilibrium expression for that reaction. Any questions? Oh, I'll put it back up there for you. It's also on YouTube. Yes, question?
In the expression, you also you do not have to like write units, write its form and that respect, if it's a gas or a liquid or whatever.
The concentrations are in the same units.
Okay.
It's always moles per liter.
Okay, so it's all moles per liter.
Right.
Maybe something not using liquids and only using gases.
Right. So we don't have to worry about that. And what we're doing at this level is we're just introducing you to the idea. And of course, there's a lot more complexity when you study this further. But we're just trying to just get a surface understanding of how all this stuff works. Oops.